How are you guys? Assalamu alaikum everybody. Today inshallah we're going to talk about the product and quotient rules. So just to remind you about the product rule. So product rule d by dx, which is the notation of differentiation of multiplying. So product is the result of multiplying. U and v are two different functions. So the rule is u dash v plus uv dash, which is derivative of the first function multiplying by the second function plus first function multiplying by derivative of the second. Quotient rule. Quotient is the result of dividing. So d by dx of u over v is equal to squaring the denominator first, then vu dash minus uv dash. Squaring the denominator, and in the numerator you're supposed to start from the denominator multiplying derivative of numerator minus numerator multiplying derivative of denominator. Let's start with one of the examples based on the product rule. So for example, d by dx of e power of 2x 1 plus 2x, u and v. So u is e power of 2x and v is 1 plus 2x. Then u dash is derivative of numerator 2 e power of 2x and v dash is 2. Then using cross multiplying, so to apply the rule, then the derivative is 2 e power of 2x, e power of 2x times 2, then plus 2 e power of 2x and 1 plus 2x. Simply, you can take 2e, these two terms, as a common factor. So 2e power of 2x, then open the bracket. Once you take that as a common factor, so only 1 is left, plus 1 plus 2x left. Now 1 plus 1, by combining like terms, you keep the 2e power of 2x as it is, then 2 plus 2x. Basically, in these types of question, if the question asks you to differentiate with respect to x or find the derivative without requiring to simplify the answers, you just keep the answer into this form, or directly you can keep it into this form. Sorry. But if and normally in the questions that with the ask you to find the equation of tangent, equation of normal, stationary, turning points questions. In these questions, no need to simplify, or maybe in case of solving the equation, you need to simplify it to make the equation simpler in finding the values of the x. So till now, as far this is the correct answer, but you can simplify it more. So as you see here, 2 plus 2x, you can take simply 2 as a common factor as well. And remember, you have 2 outside, so 4 e power of 2x and 1 plus x. That's it. Okay? So this is using product rule. Let's take another question using quotient rule. d by dx of 3x squared over 1 plus 2x power of 2. Remember to use u and v. And by the way, you can use f of x and g of x as well. So u is 3x squared and v is 1 plus 2x power of 2. Now, to differentiate, derivative of 3x squared simply will give you exactly 6x. This is normally that we did before. This is simple on differentiation. V dash, which we call the chain rule, it's 2 times 1 plus 2x power of 1 multiplying 2, which is equal to 4, 1 plus 2x. Then, because this is quotient rule, so you have to square the denominator first. It's v squared. This is v, huh? 1 plus 2x power of 2, all to the power of 2. Remember, in case of power of power, you have to multiply the powers together, not to add them. Then, you start in order, vu dash first, so 6x by 1 plus 2x power of 2 minus 3x squared by 4 is equal to 12. Multiplying up. So 12x squared and 1 plus 2x. Then we're going to take a common factor. The common factor is, for 6 and 12, common factor is 6. X and the x squared, you take the least power, which is x. And for these two brackets, because they are like terms, you have to take the like terms, or the least power. So which is 1 plus 2x power of 1. Inside the bracket, from the first term, you're supposed to show only 1 plus 2x, only one bracket of 1 plus 2x. And 12 divided by 6 is equal to negative 2. X squared divided by x is x. And no brackets left for 1 plus 2x. Over 1 plus 2x all to the power of 4. 2x and negative 2x cancelled because they are like terms and they're having different signs. So you have only 1 left inside. So that one multiplying any other term will give you the same thing. You just write 6x 1 plus 2x over 1 plus 2x all to the power of 4. This cancel the power of 4 because you have 4 brackets in the denominator. So only 3 brackets or power of 3 is left in the denominator. So 6x over 1 plus 2x all to the power of 3. Let's take this question, guys. Find the coordinates of the stationary points. This is question 11 of the textbook. Find the coordinates of the stationary points of y equals to x squared over 3x minus 1. Remember, stationary point says y dash is equal to 0. So we're going to use the quotient rule because it's dividing. So u is equal to x squared, which is the numerator, and the denominator is v, which is 3x minus 1. Derivative of the x squared is 2x. Derivative of v is 3, which is v dash. Then start in order, vu dash minus uv dash over squaring of the denominator. Okay? So vu dash, 2x by 3x minus 1, and uv dash is 3 by x squared. Over squaring the denominator. Denominator is 3x minus 1, so the squaring of that is 3x minus 1 power of 2 equals to 0. Then, using cross multiplying, so cross multiplying, you will get denominator is cancelled, and then expanding the brackets, you get 6x squared minus 2x minus 3x squared. 2x by 3x, 6x squared, and 2x by negative 1 is negative 2x. 6x squared minus 3x squared is 3x squared minus 2x. At quadratic equation, you can use mod 3. We'll find 2x values, 0 and 2 over 3. 0, of course, will give you 0 because 0 divided any number is equal to 0. Okay? And use that with the y, with the other value of the x as well to find the y coordinate. So the y coordinate using 2 over 3 is 4 over 9. So you get 2 stationary points. Another question, y equals to 3x minus 2x minus 3. It's required 2 things to find the equation of the normal at the point 0 and 0, which is the origin point. And the second required is to find the intersection point, the other intersection point between the curve and the normal. Because basically, they intersect each other already in the origin point. So again, we're using quotient rule. U is equal to 3x, which is the numerator, and v is equal to 2x minus 3, which is the denominator. Derivative of numerator, which is u dash, is 3, and the denominator is 2. Then using cross multiplying, in order vu dash minus uv dash over v squared. Again, vu dash minus uv dash over v squared. So vu dash is 3 by 2x minus 3, and uv dash is 2 by 3x, which is 6x, over the squaring of the denominator. So directly x is equal to 0 to find the normal, the equation of normal. This is the x coordinate, and of course this is the y coordinate. So by replacing x as 0, you'll find negative 9 over 9, which is equal to negative 1 from the gradient of the tangent. Then gradient of the normal is 1, because you have to flip and change the sign. Then use the equation of the straight line, y minus y1, which is the 0, equals to m x minus x1. Gradient is 1, not negative 1, because you're talking about normal. Then 1 by x minus 0, so y is equal to x. This is the equation of the normal. The second part, find the other intersection point. So in intersection point, if it's required in the question, to find an intersection point, you have to do y is equal to y. Whatever two curves, curve in a straight line, or two lines, you do y equals to y. Here is it, y, the curve is equal to y of the normal. So you just equate them because this is the equation of the curve, and this is the equation of the normal that we got before. 3x over 2x minus 3 is equal to x. Using cross multiplying, you'll get this. 2x by x is 2x squared, and negative 3 by x is negative 3x. By combining the like terms, you move 3x to the other side and you get 2x squared minus 6x is equal to 0. Now, two values of x you'll get using the calculator mode 3, 0 and 3. 0, one of the points, one of the coordinates of the origin point, so you're supposed to use the other x value. So using equation of normal is y equal to x. I find it easier than using the equation of the curve. But it's no problem at all if you're going to use the equation of the curve, because using both, at the beginning you equate them, you make them equal. So simply you can find the equation of the normal. Then y is equal to 3. So the coordinates of the other intersection point between the curve and the normal is 3 and 3. Here again, question 15. The question asks you to show that the derivative of this curve is equal to k. The second derivative, is k over 1 minus 4x power of 3. Find the value of k, and find the value. You're supposed to find the value of the k. K is a constant, by the way. Again, quotient rule. U is the numerator part, 1 plus 2x, and v is the denominator part, which is 1 minus 4x. Derivative of u, 1, 0, 2x is 2, 1, 0, and negative 4x is negative 4. Then vu dash minus uv dash over v squared. Don't forget this rule. This is the quotient rule. vu dash minus uv dash over v squared. Start with the denominator, 1 minus 4x to the power of 2. Then vu dash 2 times 1 minus 4x. And then 1 plus 2x by negative 4. And remember, in the rule you have a negative, by the way. So negative by negative will make that positive. By expanding, 2 by 1 is 2. 2 by negative 4x is negative 8x. 4 by 1 is 4. And 4 by 2x is 8x. Negative 8, positive 8 cancelled. 2 plus 4 is 6. And you keep the denominator as it is. For myself, I find it easier to find the second derivative using chain rule, because you don't have any x in the numerator. And I told you, you never go to product and quotient rule only in one case, if you have more than one x on the function. So as you see, you have only one x in the denominator, so you can use chain rule now by moving the denominator and change the sign of the power. So using chain rule in 3 steps, negative 2 by 6, negative 12, step number 1. Step number 2, write the same expression, but you have to reduce the power by 1. Negative 2 minus 1 is negative 3. Then multiplying by derivative, which is negative 4. Negative 4 by negative 12, 48. And then you move that in the denominator, and you got the value of the k as 48.